Hello viewers, I hope you are all fit and fine. Previously, I have released one video of Area Moment Theorem. I will rename that video as Area Moment Theorem Part 1. So I am going for the Area Moment Theorem Part 2. With the same cantilever beam, I am showing the few steps with the cantilever with point load and cantilever with UDL. And I will again go for a Area Moment Theorem Part 3, where I will discuss some about the simple supported beam with UDL and point load. So let us take one case here. This is one cantilever beam having a point load W at its end, and C is the midpoint. So we are to find a deflection at the point C with respect to the tangent drawn from the point A. We are to find a deflection YC, that is deflection at the point C, deflection at the point C, with respect to the tangent drawn from A by area moment theorem. So let us draw the M by EI diagram. EI is the flexural rigidity here. So if we draw the M by EI diagram, it will be a triangle, and we are to find deflection at the point C. This is A, this is B, and we have to find the M by EI diagram. Here it is WL by EI. This is M by EI diagram. M by EI diagram, and here it is WL by 2EI. Now let us divide this part into the two parts, that is, one is the rectangular part, another is the triangular part. So let us draw here it separately. This is the rectangular part. The length of this rectangular part is L by 2, and this width is WL by 2EI, and the CG distance is, this is L by 4. L by 4. Similarly for this triangle 2, let us take this triangle 2. So this is one is this rectangle and this is the triangle 2. This length is L by 2, and similarly this altitude on the height, this is WL by 2EI, and this CG distance will be 2/3 L by 2. This CG distance is actually 2/3 L by 2. The CG distance here is 2/3 into L by 2, that is equal to L by 3. So for deflection at C, YC is equal to the area of the rectangle, that is area of rectangle 1 into CG distance plus area of triangle 2 into CG distance, that is equal to L by 2 into WL by 2EI into L by 4, this is distance, plus half into L by 2 into WL by 2 EI into L by 3. This is equal to WL cube by 16 EI plus WL cube, if this is for this is 4 8 24 EI. This is equal to WL cube by 48 EI, which is equal to 3 plus 2, which is equal to 5 WL cube by 48 EI. This is downward for this negative sign. So this is the deflection at C from the tangent drawn from A. So let us find another case. This is a cantilever beam having a UDL of W kN per meter. EI is the flexural rigidity. We have to find deflection at the point C. So we have to find YC equal to deflection at C with respect to the tangent drawn from A. So let us draw the M by EI diagram. This M by EI diagram will be a parabolic curve. So a parabolic curve, and here it will be WL square by 8 EI. This is M by EI diagram. By EI diagram, and the CG distance here is 3 by 4 into L by 2, that is 3L by 8. So this YC will be equal to 1/3 into L by 2 into WL square by 8 EI into 3L by 8 plus L by 2, the distance up to the point C, that is equal to WL cube 48 EI by 8 L plus 4L, which is equal to 7WL to the power 4. This is 384 EI. So the arrow for the downward, for the negative sign. So this is YC for a cantilever having a UDL up to its middle of the length. So here we will be taking another case, that is a cantilever beam having a point load W at the midpoint. We have to find the deflection at the point C with respect to the tangent drawn from A. Here EI is the flexural rigidity. EI is the flexural rigidity. We have to find the deflection at the point C. YC is equal to deflection at C with respect to tangent drawn from A. So let us draw this M by EI diagram. this will be M by EI diagram, and this will be a triangle, and here it is WL by 2EI, and its CG is 2/3 into L by 2, that is equal to L by 3. So YC will be area of the triangle this is actually M by EI diagram, M by EI diagram, area of the triangle or area of the M by EI diagram into CG distance plus distance of C from B, that is equal to half into L by 2 into WL by 2EI into L by 3 plus L by 2. This is equal to WL square by 8EI, and this is 6 is 2L plus 3L, which is equal to 5WL cube by 48 EI. A downward arrow shows the negative sign. So this is the deflection of the point C with respect to the tangent drawn from the A for a cantilever beam having a point load W at the midpoint, and we have to find deflection at the point C. This is one of the most important criteria of finding deflection by moment area method. This is a cantilever having a throughout UDL, and we are to find deflection at the point B with respect to the tangent drawn from A. EI is the flexural rigidity, the UDL is W kilonewton per meter. So we are to find YB, that is deflection at B with respect to the tangent drawn from A. Tangent drawn from A. This is very crucial thing so far as this area moment theorem is concerned. So let us draw the M by EI diagram. M by EI diagram with a parabolic curve. So we are to find deflection at this point. Here this will be WL square by 2EI, and at this point this will be WL square by 8EI. So while finding this, don't go for the separation of this triangle and the parabolic curve, because this is not a linear curve, this is a parabolic curve. So you have to first find the area of the entire parabolic curve, then you have to subtract the area of this part, and you have to work out. So the area will be 1/3 into WL square by 2EI into L minus 1/3 into WL square by 8EI into L by 2. This is equal to WL cube by 6EI minus WL cube by 48EI. This is equal to WL cube by 48EI. This is equal to 8 minus 1, which is equal to 7 WL cube by 48 EI. Now let us consider x bar from the point C. So x bar into 7 WL cube by 48 EI be equal to WL cube by 6 EI into, this is 3 by 4 L, 3L by 4 minus WL cube by 48 EI into 3 by 4 into L by 2. This is equal to WL to the power 4 8 EI minus, this is 16 into 8, that is WL to the power 4 by 128 EI. Here it is. So we will take WL4 by 128 EI. This is 16 minus 1. This will be equal to 15 WL by 4 128 EI. From here we have to find x bar, or x bar will be equal to 15 WL to the power 4 128 EI into 48 EI by 7 WL cube, EI gone, WL cube, and this is gone, this is only L. So after evaluating this will come in the tune of 45 by 56 L. So now we have to find the CG distance from the point B. So the CG distance from B will be equal to 45 by 56 L minus L by 2. This is going to be equal to 17 by 56 L. So the deflection at the point B will be YB will be equal to 7 WL cube by 48 EI into 17 by 56 L. This is equal to 17 WL to the power 4 by, this is 384 EI. So this will be the deflection of the point B with respect to the tangent drawn at A. Remember one thing, it is never like this that you will just segregate this in the similar way we have done for the point load. You deal with a point cantilever with a point load. and we will consider this as a rectangle and this as a parabolic curve. We'll take this as another parabolic curve. So this is not anyway it is not like that area of the area of 1 plus 2 plus 3 is never equal to the area of this whole parabolic curve, area of whole parabolic curve. So this is to be if this type of problem comes and you were asked to deduce by means of area moment theorem, so due care should be taken. The calculation should be in this way. In no way it should be segregated by this type of means. Actually, in case of exam, it is better to carry out this type of problem by means of double integration. It is quite easier, but I have done it if for the higher studies there is a scope of finding this type of deflection by means of area moment theorem. So this can come very handy there. So if you are impressed by the approach that I have made to make you aware of this situation, then please press the like button, share it, write comments, and inspire me so that I can explore more for this type of activities. This is Devroti Chakraborty signing out till we meet again.